Hello. Hi. I don't know whether that worked or not. So this is notes 4D. This is on the applications or uses of heat. So the beginning, as usual, is the quick review. Please pause, use the word bank, fill it in, unpause to get the answers. All right, welcome back. Here we go. The type of transfer that's direct contact is conduction. And then the one that's left is radiation. Conduction is direct contact. Convection is circulation. And radiation is waves. To draw the arrows for conduction, we've got the quick exchange of two things that are right next to each other. For convection, we have our circles and the radiation arrows done for us. An example of conduction: bare feet on hot sand. And wind currents is our example for convection. And for radiation, lying in the sun. Pause it if you need to, but I'm moving on. All right, so when you live in a newer house or a house that has a furnace or central heating or something like that, not a wood stove, usually when you get cold, like if you live in a house with a wood stove, you get cold, you chuck more wood in the fire. But in a house that has either a furnace or a central air, when it's cold, you go and turn up what's that device called that's on the wall? If it's older, it's round and has a little dial in it. If it's newer, it's square and has numbers. Exactly, a thermostat. So it's getting cold. Let's turn up the thermostat. So what is a thermostat? A thermostat is a heat regulating device. It uses the fact that things expand when heated, and this is called thermal heat expansion. So expansion due to heat. And all things do this. The Eiffel Tower can be 4 to 6 inches taller in the summer than it is in the winter due to thermal expansion. All that metal gets hot and it expands. Crazy to think about. When you drive across bridges, very often you'll see like a zipper looking thing made out of metal teeth. And that is there, but it's taking advantage of thermal expansion. It's there because bridges freeze faster because there's no ground underneath them to insulate them. And so those materials expand and contract, expand and contract. And if you didn't allow for that, your road would buckle and fall apart. So they put in those teeth, those metal, it's just a metal grate with these teeth, and they slide together when it's hot and they are pull apart when it's cold, but not enough for the bridge to fall apart, just a little bit. When they build railroad tracks, they don't put the two rails right next to each other because when it got hot and expanded, they buckle. There's a little gap when they put those rails down. They don't put them right next to each other. There's a little bit of gap, and that gap allows for that thermal expansion. And the gap isn't big enough for those big old train wheels to mind it. So thermal expansion is the fact that when things get hotter, they get bigger. So in our thermostat, it uses that fact, that thermal expansion, to control a switch which is connected to your furnace or your central air or your air conditioner or whatever your heating system is. There are two types of metal. It's called a bimetallic strip. So bi meaning two, like bicycle has two wheels, and then metallic meaning metal. So it's made out of two different metals. And one of the metals expands at a slightly different rate than the other. So when you have these two pieces of metal side by side, but this one expands or contracts faster, it starts to curl, it starts to bend. And when we get that curve, we get that bend in the metal, it bumps into the switch that turns on or off the device. So like if you have it set to 80 degrees and it gets down to 79, the thing straightens out and bumps and makes the heat come on. And thermostats are used in anything that heat is regulated in. So ovens, toasters, electric blankets, central air systems, air conditioners, anything that you, refrigerators, anything that you, we already said furnace, so I'm going to put refrigerator. So they're used in anything that heat needs to be regulated in, an electric blanket, a heating pad, anything that you want the heat to stop after a certain point. All right, make sure you pause and get that written down. I'm moving on. The next device we're going to talk about is a heat engine. So a heat engine is a device that converts thermal energy into mechanical energy. They usually make use of combustion. And that's a word that y'all are supposed to know. Combustion. What's it mean when something combusts? Right, burns up. So explodes. So combustion is burning. So combustion is the process of burning a fuel such as, such as wood or coal or gasoline or diesel. During combustion, the chemical energy stored in the fuel is converted into thermal energy. And then that thermal energy, the heat, is then applied to the engine to create motion. So there's actually more than one type of heat engine. So heat engines are classified according to whether the combustion takes place inside or outside of the engine. All right, again, pause it if you need to. I'm clearing it and moving on. All right, so our two types are external and internal. And you can imagine what that means. External, outside, internal, inside. So external combustion means that the fuel is burned outside of the engine. A steam engine is an example of this type of engine. So when you saw videos and movies that had people running a steam engine, there would always be somebody shoveling coal into a boiler. Well, there's not a person inside the engine shoveling coal. So that boiler has to be separate from the engine. It's the burning is happening outside of the engine. It's two different places. So the burning of coal, wood, or oil heats water in a boiler outside of the engine. As thermal energy increases, the water begins to boil. The steam gathers force and begins to push against a metal plunger called a piston. The piston moves back and forth inside the cylinder. Thus, heat has been converted into mechanical energy. So the steam creates enough energy to make the piston move back and forth, and that is where that comes from, okay? And that's a steam engine. So what about internal combustion? So I actually have a model of an internal combustion engine here. And the main reason I want to show you this is because I want to show you what the axle on the underside of a car looks like and how the up and down motion of the pistons inside the cylinders creates that up and down motion. So maybe you can see these little wooden things here. Those are the pistons, and they're moving up and down. And you see how they're moving up and down, but I'm turning this going this way. So the shape of this crankshaft, this up and down shape, is what makes that happen. So in an internal combustion engine, it means that the fuel is burned inside of the engine. Diesel engines and I'm getting ahead of myself. Internal combustion is inside the engine. So gasoline and diesel are both internal combustion. So the bus, the diesel trucks and that, as well as gasoline powered cars, are all internal combustion. So diesel and gasoline power most vehicles that you've heard of. There's very few steam engines left out there. It works almost the same in that we have a piston inside the cylinder moving up and down, which turns the crankshaft, and that is the same. It's the same thing. The difference is, where does the fire take place? So there are 4 strokes to the 4-stroke engine cycle. And whether you've got 2 cylinders on a little teeny motorcycle engine, or whether you've got 8 cylinders in a big old car engine, and that's, you've ever heard of a V8 or a V6, that's where that comes from. V6 or straight 8 or straight 6, that means the number of cylinders it has and then what formation. So a V8 means 8 cylinders in the shape of a V. So there's 4 here in the shape of a V. Straight 8 means it's 8 cylinders in a straight line. But it's just one of these cylinders. Now, what I need you to understand is that this process, the 4 strokes, happen in every single cylinder. For some reason, because we've got these 4 here, people think, well, that's the intake cylinder, and that's the compression cylinder, and that's the power cylinder. No, you need to know that you could have an engine that had 1 cylinder, and it does all 4 of these strokes. Okay, so the first stroke is intake. The exhaust valve is closed, the intake valve is open, and it draws in air, and it also draws in fuel, but it's not liquid fuel, it's sprayed in a fine gas. And so this is why it's called gas, even though it's a liquid when it goes in our car. So that gets ignited, and we know that things won't burn without air. So if that's plugged up and air isn't coming in, that's why your engine won't work, because it's not getting any air. The piston pulls down, and it creates suction and pulls that air and gasoline mixture in. Then on the compression stroke, both of the valves are closed, and the piston goes up and squeezes that air and gasoline mixture together and puts it under a lot of pressure. Then the spark, bam, fires, and it fires into that compressed mixed gas and air, and it slams that piston down. It forces that piston to go down, and that piston converts that down and up energy into the forward motion of the car. And then finally, last step is exhaust. The exhaust valve opens, the piston pushes up and pushes that burnt air out, and then the process starts again. And you need to know it's fast. It's boom, 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 boom. Like, I can't even do it as fast as it actually happens. So what are the 4 strokes? Intake, compression, power, exhaust. Intake, compression, power, and exhaust. Intake, compression, power, exhaust. And we have here on our model, I mean, it's probably backwards for y'all, I don't know, but we can see where the intake and the exhaust valves, and if I had some spark plugs to put in, they would go up here, and we could have a lovely little engine model. But the main thing I wanted you to see is how the crankshaft is shaped, makes it so that up and down motion gets converted into back and forth motion. All right, again, pause if you need to get that written down, but I'm going to move along. All right, so turning a crankshaft. This motion is transferred to the wheels of the car. You can see in the picture how this works. You can also see from the image that the gasoline is burned inside the engine, inside the cylinder. 1 up and 1 down motion is called a stroke. Most engines you are familiar with are 4-stroke engine. All right, for this next bit, I never claimed to be any good at HVAC, which is heating, ventilation, and air conditioning. If this interests you at all, and if you get it at all, then you should plan on going into HVAC and making lots and lots of money. Because I kind of get it, but I only kind of sort of get it. I'm going to write these notes down. And if you want to know more about how refrigeration works, you might want to look up a YouTube video, because I kind of get it, but not well enough to teach it. Everything else I teach, I get well enough to teach. For this, what you've got to know is that a refrigerator does the opposite of normal. Normally, heat moves from a warm area to a cold area. A refrigerator manages to move heat from a cold area out into the room, into a warmer area. That's the basics of a refrigerator, or the part at least that you need to know for me. If there is no such thing as cold, how does a refrigerator work? It gathers the heat energy from inside of it and moves it out into the room. So that's the part you need to know. That's your TQA. It moves from a cold area to a warmer area. It has a motor that runs a compressor that compresses the refrigerant, which creates pressure and heat. As it loses heat, it cools and condenses into liquid. When the heat then forces the liquid to evaporate, it cools, and that super cold gas is pumped through the tubes inside the fridge, And then in that way, the air is removed, the cold or the heat is removed from the fridge. It's sucked into that cold stuff in the refrigerant and then moved out into the room. But the part you really need to know is a refrigerator takes heat from a cold area to a warm area. If you want to know more than that, look it up on YouTube. Sorry. All right. Have a lovely day. Make good decisions. Bye.